All right, for the last couple of days, we've been talking about sine and cosine, tangent, regular trigonometric functions, and we're going to continue talking about angles, but we're not going to talk about angles that are just measured in degrees anymore. We are going to start to talk about something called radians, which is finally you're going to get to use your calculator in radian mode, so that should be really exciting. The first thing we do is need to learn a little. The first thing we need to do is learn a little bit of vocabulary. So we're going to be talking about angles in something called standard position. So we need to know what standard position means when a problem says an angle in standard position. So an angle in standard position has its initial side oriented along the x-axis. So what that means is its initial side is along the x-axis. So there's one side of my angle, and its vertex at the origin. So that's the origin right here. And that's just any angle that you'll see. It'll look like this. It'll have its initial side along the x-axis. So we're going to refer to that as the initial side. Now, if this side has a name, the other one's going to have a name. And this is called the terminal side. And you may have heard this in physics, so it's maybe a review. The measurement of our angle means how far it opens from the x-axis is going to be called theta. This little Greek symbol, and we're going to treat it just like an x in almost all of our problems. It's going to be treated like a variable. There's even a button on the calculator for it, same as the x button. And so the measure of an angle describes the angle and direction of rotation to rotate from the initial side to the terminal side. And what that means is, if we say an angle is 45 degrees, that means that it went up 45 degrees from the x-axis. If we said it was negative 45 degrees, that means it went down 45 degrees from the x-axis. So positive angles are generated by counterclockwise rotation, and negative angles are generated by clockwise rotation. You just finished doing a bunch of rotation stuff in physics too, so this should all be marginally familiar. There's two units of measurement for measuring angles. The first one is degrees. This is the one that you're familiar with and we've been working with. So example would be 45 degrees. The new unit that we're going to start working with is called radians. And an example of how a radian is written is pi over 4. And that's approximately equal to 0.785 radians. And we'll learn more about this later, but these two are actually congruent angles. They're both represent the same angle, just one in degrees and one in radians. So the definition of a radian: a central angle, that's this angle right here, theta, has a measure of 1 radian if it intercepts an arc with the same length as the radius of the circle. So in this picture you see over here, our radius equals the s, which is our arc length. And that's actually a capital S, but not a big deal. So for example, if this is 1 foot, this distance along this circle is 1 foot. Now it's curved, but it's still 1 foot. There are exactly 2 pi radians in one circle or rotation. 2 pi is also equal to 6.28. That's just 3.14 times 2. So if you look over at this circle, and you may remember that the circumference of a circle is 2 pi times r, right? Well, if your r is 1, then it's just 2 pi, right? If r equals 1. So if we look at this circle here and we went all the way around it, the distance all the way around it is 2 pi. So that's what radians are. It's the distance around a circle. If we split that up, we have 1, 2, 3, 4, 5, 6 radians And then we also have this 0.28 left over right here. And that comes out to exactly 2 pi radians. So don't get too worried about this. We're going to spend about the next month on this, so it's not too bad right now. How do we convert from degrees to radians? So let's say we have an angle that's 50 degrees and we want to convert it to radians. Well, to convert from degrees to radians, we take our degrees and we multiply it by pi over 180. And that's going to convert it. We'll practice it in a minute. And to convert from radians, we take our radians and we multiply them by 180 over pi. A real easy way to remember is that radians have a pi in them. So if we're going to go from radians to degrees, radians already have a pi. So when we multiply with a pi on the bottom, that's going to make them cancel. So if you have a hard time remembering, try to do it that way. So convert the following angle measures. So 260 degrees. We're going to convert it from degrees to radians. So we're going to multiply it by pi over 180. Well, just multiply straight across. That's 260 pi over 180. We're going to simplify that into 13 over 9. And I'm just taking the 260 over 180, simplifying it down to 13 over 9. Pi just goes along for the ride. All right, 3 pi over 4. Well, that's radians. So to convert it to degrees, we're going to do it by 180 over pi. And here's what I was talking about. There's a pi on the top, so I do the one with the pi on the bottom. The pi's cancel each other out. And then 3 times 180 divided by 4 is 135 degrees. All right, 5. Now, it doesn't have a degree, so that means it's a radians. So we're going to multiply it by 180 over pi. Now this is going to be a little bit different in that we're not going to have the pi in the answer. We're just going to do 5 times 180 divided by pi is 286.5 degrees. Because remember, we were wanting to go to degrees, and degrees don't have a pi. So even though we had this pi left over on the bottom, we still went ahead and divided it. All right, negative 145 degrees times pi over 180 is negative 145 pi over 180, which reduces to negative 29 pi over 36. So that's how we do degrees to radians and radians to degrees. All right, last thing we have to get to is something called coterminal angles. Angles that have the same initial and terminal sides are called coterminal angles. Coterminal angles are generated by adding or subtracting increments of 360 or 2 pi. An angle theta has infinitely many coterminal angles. I'm going to show you exactly what that means. Sounds complicated, not that bad. So here we have an angle, and we're going to say that it's 45 degrees. Well, remember, here is the initial side, and then the blue is the terminal side. And we open this thing up 45 degrees. But we could also have done this. Right? 360 degrees, and then stop right there. So I've taken this big angle that goes over 360 degrees around, and 45 more. So my first angle was 45 degrees. My next angle was 45 degrees plus 360, which equals 405 degrees. So the red spiral on here represents a 405 degree angle. That might be kind of different to think about, but you'll get there. All right, something else we could have done when we were opening our angle is we could have gone from right here and opened this way from that red line. All right? So that would have been, we started with a 45-degree angle, and we went 360 degrees in the opposite direction, right? Because if we were on the blue line where the 45 is and we wrapped around back to it, that would be 360 degrees. So that is negative 315-degree angle. And what you're going to find is we're going to do a lot of problems that say, find the, this is a coterminal angle, or find a coterminal angle. And what you're going to find is we're going to do a lot of problems about 405-degree angles and negative 315-degree angles. And you're going to see that if you just know things about a 45-degree angle, you're going to know everything about all of its coterminal angles. So this is some really handy stuff. All right, so quick example. Find two angles, one positive and one negative, coterminal angle, coterminal to the given angles. So 110. So we're going to do 110 plus 360. And that gives us 470 degrees. And we're going to do 110 minus 360. And that gives us negative 250 degrees. See, nothing to it. Here's where it's going to get weird. So pi over 4, right? Now, we said up here that we can add increments of 360 or 2 pi. Because remember, every time we go around this circle, it's 2 pi all the way around it, right? 2 pi is one time around the circle. So we're going to take our pi over 4 and we're going to add 2 pi. Well, that's pretty easy, except we need a common denominator. So 4 is going to be our common denominator. So 2 pi, to turn that into something with a 4 on the bottom, is going to be 8 pi over 4, because 8 and 4 reduces to 2. So this is all good. Pi times pi plus 8 pi is 9 pi over 4. I bet y'all are loving that, huh? Now we're going to do a negative one, pi over 4 minus 2 pi. We're going clockwise now. So that's pi over 4 minus 8 pi over 4, right? That keeps me at my 2 pi, because 8 over 4. So this is negative 7 pi over 4. Not so bad. Negative 260. So we have negative 260 plus 360, one time around the circle. And that equals 100 degrees. Then we'll take negative 260, and we're going to go 360 degrees the other way around the circle. And that gives us negative 620 degrees. All right, now here's an interesting example. Okay, we're going to do 565. And we're going to go one time around, 360. So that gives us 925. Nothing special. But now we're going to do 565 minus 360. And that gives us 205 degrees. But the instructions said we need a positive and a negative. So we're going to have to do another wraparound, another loop around. So that's negative 155 degrees. So if you were looking at this negative 155, you would say that negative 155 equals 565 minus 360 times 2. That took us 2 loops around. And something you're going to see, and this is just a notation thing for you, so you're going to see angles written like 565 minus 360k. And k is going to equal 2 in this specific case. So it's just so you can start to get an idea. When you see the minus 360k, that means subtract 360 however many times k is. So they might tell you k is 2 or k is 15. And that'll tell you how to find your angles. So that's it for the video. Hopefully not too weird. And we'll see you tomorrow.